Let's begin section 10.3, polynomial and rational functions. Now we've studied already the parabola, actually the quadratic, and the square root, functions, as well as linear equations. And now we're going to do polynomial. Poly meaning many. Nomial means terms, many terms. So a polynomial function is a collection of terms with variables and different degrees. Greater than 1. In other words, it can't be linear. It can be it can still be a polynomial, and there can't be degrees that are fractions or other things because they imply other concepts. So here's what the polynomial looks like. Some coefficient to x to the n, meaning the largest degree, and in descending order. And the a's of 1 are called coefficients, and they cannot equal 0. And it is called the leading coefficient, any letter on the top. All right. So what are the properties of the function? All right. Well, the largest degree, well, the largest exponent, sorry about that, I'm getting ahead of myself. Polynomial function is called the degree of the function. All right. So if I have f of x equal to x cubed minus 4x squared plus 3x minus 6, then we know that the degree is 3, the largest exponent. Well, if I have f of x is equal to x to the 6 plus 6x to the 4 minus 3x squared plus 9, well, then the degree 6. All right. Now, that brings about the identity of odd and even. So a degree degrees 2, 4, 6, etc. are even functions. And degrees of 3, 5, 7, etc. are odd functions in the polynomial family. And this brings about and in tendencies. Now, these are clues to what the function may look like, right? So, if I have the first one, this one, a degree 3 odd polynomial, I can have at most 2 turning points. That means that I have the degree minus 1 is how we figure the turning points. All right, well, what exactly does that mean? Well, we're going to do a little bit of a sketch. So this means that I have a function that has 1, 2 turning points, but it is at least a degree 3, okay? Depending on how it kisses the x-axis and so forth. But for us, it would be odd because it goes from negative infinity to positive infinity on the extremities. All right, so if we had a degree 4 polynomial, that's an even polynomial, would have, and my pen decides when to write and when not to write, sorry. So we have an even polynomial. Well, then we have, supposing we have g of x equals x to the 4 minus 3x cubed plus x squared plus 2x minus 1, whatever. Okay, we have that guy happen. Well, that means that our graph goes like a W. Right. Notice that if it's a positive in the front, then we have them both aiming, both in tendencies positive. And we would have 4 minus 1, 3 possible changes. Here's 1, 2, 3. And so it's n minus 1. All right. Well, then we know that if it's negative, well, then it would go in the opposite direction, from positive infinity to negative. And the same goes with this W. It would become an M. All right. So now we're going to talk about how does it look? How does it look? Now, we're going to use our calculator. But for starters, let's look at the degree. So we want to know that the degree of this function, y equals x cubed minus 5x minus 15, is 3. So it must have n minus 1 turning points. So we would get 3 minus 1, 2 turning points. Right? So we know this. Then, so we have 2 turning points, and it is positive. The coefficient is positive. So that means that it goes from negative infinity to positive infinity. Negative to positive, because it's not reversed. All right. So immediately we know that it has at least 2 turning points. So here's 1, 2, 1, 2, and this has many. 1, 2, 3. So it's not that one. And this one's even because they go to the same extremity. So that's not it either. Now, so we know it has to sample this. So we know that our answer is B. But we want to see it on our calculator. Now notice that it is a 10 by 10, a 10 by 10. So we're going to use our calculator. I'm going to go to the y equals, and we're going to enter this. Second row, second key, up caret 3, and I'm going to do the side arrow to bring it back down, minus the 5x, minus the 15. All right, and then I'm going to do zoom 6, right? Because that's a 10 by 10. And we can see that this one does not work very well. I don't see the curvature. Let me look at what I wrote. X cubed minus x minus 15. Oh, it's 100. Oh, sorry. My window has to be 100. I am so sorry. So the 10 and the 10 is good. But this guy is a negative 100. And then the bottom one is a positive 100 for max. And we're going to do them in, let's do them in, 10 is good. Oops. Let me look at my window. Let me enter. What did I write on my window? Hold on. Negative 10, positive 10, negative. Did I put a minus instead of a positive 100? Yeah, I got it right. Y min. Oh, the scale. Oh, mercy sakes. This is a negative 100, a positive 100. Oops. Sorry about that, class. My pen is acting up, isn't it? Scale of 10, sorry. So there we have it. And you can see that we guessed correctly on that. See, the curvature is in truth that. All right. Well, we have another one here. And this one is an even polynomial. Of degree 4. So therefore we have 4 minus 1 turning points. Possible. If they're perfect squares, it's a different story. So we know it can't be this one. And we're stuck with, so 3. This one has 1, 2, so it's not that one. So it's between these two. Well, it's positive. Now notice that we have a plus 13, which means it's a shift up of 13. So we'd have to say it's this one. And we're going to talk about that right now. And we know this is very huge. And I don't see, oh, here's the way we set the window. So we're going to go to our calculator, go to the y equals, we're going to clear, and we're going to enter this polynomial. Second row, second key, up caret, and we're going to put a 4 side arrow, plus 7x squared, so we can hit the x squared key without having to come back down, plus the 13. All right, so we're going to go to our window, and we're going to do a negative 10 and a 10 and a 1. And here we're going to do a negative 50 and 50. And then we're going to do a positive 50. We're going to do a scale of, 10 is good. So we're going to put a scale of 10. And we're going to graph it. And there it is. So we guessed right that it was there. This is 13. So if I did a second calc value at x is 0, I would get 13. So there you go. All good. So we got that one. Now this one is asking, the given graph is a graph of a polynomial function. Give the possible values of degrees of the polynomial, and signs plus or minus for the leading coefficient. All right. So we want to know the turning points, how many it has, and we want to know the end tendencies, which tell us if it's even or odd. All right. Well, the turning points are 1, 2, 3. So we have at least a degree 4. It is positive because the end tendencies are both positive infinity. So we know it's even and it is a positive. Okay, the possible value. So we can say it is at minimum a 4, a 6, an 8. That's pretty big. The computer asked for 3. And then it is the sign, the leading coefficient, is positive. So that it points to infinities in the same direction. All right, nothing difficult here. So here we have an odd because it is negative infinity to positive infinity. So this guy is an odd polynomial. We're working a little bit better. We know that it has 1, 2, 3, 4 turning points. So at the smallest, it is a 5 degree polynomial function. And a positive leading coefficient. Might ask for several if it wants. If it wants more than one, it would have to be the 5, the 7, and the 9. All right. So now we're changing gears to something that's very critical in business economics, mathematics, and that is the rational function. Now this brings about, and that means a fraction. Ratio means fraction. So we know we have this condition here. It's a fraction. And the top has variables sometimes, and the bottom definitely has variables sometimes. But we also know that the denominator cannot equal 0, because then it is undefined. And in this section, we're going to find out what we call that condition. That condition is called a vertical asymptote. To find vertical up and down asymptote, set denominator equal to 0, solve for x. That gives you that vertical line where x equals that value. All right. If the value of y approaches a number k, as x, absolute value of x gets larger and larger, the y equals k is called a horizontal asymptote. Now, a horizontal asymptote is when, let me get some room, when degree of numerator, sorry about that, let's start in the top. Of denominator. Right. And then, therefore, the coefficients of the numerator and denominator is the y equals the coefficient of over coefficient of denominator. And this is the horizontal line. Horizontal. Vertical is when there's a 0 can happen in the denominator. And we have some special cases that we're going to be talking about. All right, so we're going to choose the graph. All right, but we're going to study what we have. Now, the bottom will never equal 0. So we do not have a vertical asymptote. That means there's not a line that can be drawn to separate because it's discontinuous at that point. All right, because it's an x squared. So if I use a negative or a positive, it'll never be a negative because the square of both of those is 0. Then we notice that we have 2x squared over x squared. So these match. So we have y equals 2, which is the leading coefficient, 2 over 1. Y equals 2, we have a horizontal. Right. And now we can see about an x-intercept. So, a y-intercept. So a y-intercept is when x is 0. So we've got a 3. So now we have that. We don't have any x-intercepts, but we do have a y-intercept. It is continuous. Well, this one is negative, so that doesn't fit the bill. It doesn't have a vertical asymptote, nor this condition here, to my way of thinking. Have that y equals 3 horizontal line. So it's going to be the first one. But we're going to double verify because I made you buy a this calculator. So make sure we got that down. So let's look at our calculator. Ready? Y equals, and we're going to learn about entering a rational function. Okay. Let's see on this one. So we're going to go under y equals, choose y1, and then we're going to enter, and this is what we're going to enter, parenthesis, 2x squared plus 3, close parenthesis, divided by, open parenthesis, x, and then we want the squared, plus 1, close parenthesis. All right. Now, this is called enclosing an argument. This is the numerator, and this is the denominator. And we don't separate them. We keep them together because it's the argument for the condition. And we use parentheses. So here we go. Ready? So I'm going to open parenthesis above the 8, and I'm going to enter 2x squared plus 3, close parenthesis, divided by, open parenthesis, x squared plus 1. All right, now I'm going to go to zoom. I think we can do 6, standard window, and we have that. And we guessed correctly. Does everybody see that? Yes, ma'am. And we can see that the horizontal asymptote, we can add it. And we said it was 3. So let's graph that. And you can see that it doesn't cross that line. All right. Now, I've got this guy right here. And I don't know. So what I'm going to do, I don't know how that happened. I have y equals x plus 7 over x minus 4. And what we want is if it has any vertical asymptotes. All right. So this means we, what? Set this guy equal to 0. So we do have a vertical asymptote. Now we want to see if we have a horizontal asymptote. Sorry about that. So that would mean that I have my degree is x over x, so the number is y equals 1, because there's a 1 there and a 1 there. So y equals 1. And we could check with our calculator because we want to get comfortable with using our calculator. So let's clear that, go back to y1, and again get practice. Open parenthesis, x plus 7, close parenthesis, divided by, open parenthesis, x minus 4, close parenthesis, and I think I'm on 6, and there we have it. And now, what we know, we have an asymptote at is 4, but we'll do that, check that. But we want the horizontal. We said y equals 1, so here we go. And there it is. The graph will never touch 1 on both extremities. And we can do a second count and do a value. And we said it was 4. And it'll say nothing because it does not exist. Does everybody see that? All right. So here we want any horizontal or vertical asymptotes and any holes that may exist. Now that's called a removable point, and I haven't done one yet, and I don't think I have one on the homework, so we don't have to really worry about that. So let's look at this guy, and then it said draw the function, including the x and y intercepts. All right. So here we go. So if there is an x to the 0 in my numerator, because anything to the 0 is 1, because it's not there, and an x on the bottom. So x to the 0 is less than x, and therefore we have y equals 0. This is a theorem. If degree of numerator is less than denominator, the one-way conditional, then y equals 0 is the horizontal. Right, horizontal asymptote. So we have this condition. Now we're talking about our vertical. So we're going to have 5 plus 2x cannot equal 0. So we're going to solve for x. So I'm going to have 2x equals negative 5. If I divide by 2, I get a negative 2.5. So this is my vertical. All right, if I have x equals 0, and my y-intercept is 5 over 5 plus 2 times 0. So I get y equals 1 is my y-intercept. And then I have, let's see if I have an x-intercept. Well, I can't, because then it'd be undefined. So I only have a y-intercept. So it said, well, how would we draw this, right? Well, let's look at that. So it's not going to be good because I'm drawing it, but we'll do okay. Let me take my shape here. I'll try to be as good as possible. Talking about an idea. Of course, you can use your calculator, and we might if we want to. All right, what we want to do is state y equals 0. So I have this line right here for my horizontal. My vertical is negative 2.5. So I'm going to do that one next. 1, 2, 3. So I'm going to say this is my, vertical. All right. So this means, and then I have a 0 and 1. So I'm going to say that's my 0 and 1. And I know it can't cross. So maybe it goes this way, and then it goes this way. So we're going to find that value as it approaches that 2.5. So negative 2.5. So we're going to let x equal a negative 3. That's on this side. So if x is a negative 3, I have 5 over 5, y equals 5 over 5 plus 2 times negative 3. So I'm going to get a what? Well, that's going to be a 5, and this is a negative 6, a negative 1, negative 5. All right. So at negative 3, I have a negative 5, so it's down here. This means this line goes like that. Now I'm going to, okay, because that gave me a negative 5. So I'm going to do a negative 1. That's on this side. And let's see what that is. Or I should do a negative 2. Let's do a negative. Okay. Now I'm going to have y equals a 5 over 5 plus 2 times a negative 2. Well, that is 5 over 5 minus 4. So that would be a 5 over 1, 5. So the negative 2, I have 5, which is about right here. So this means I'm going like this. All right. So now we know, because it's not going to cross that red line, the horizontal, and it's going to go down. All right. And I kind of drew it kind of crazy. You'll have a selection. Let's see how good we are. All right. Hear it? I'm going to clear the next one. All right. Oops, sorry. So I'm going to go to Y1, and I'm going to say 5 divided by, open parenthesis, 5 plus 2x. Oops, sorry. Sorry about that. 5 over 2x, close parenthesis. And notice I only have the argument in the bottom because that's where the variable is, and another term. It's a binomial. So I just needed that one. And we know this guy is at 0. All right, so we're going to do zoom 6 just because I forgot if I... And looky there. Didn't I draw something very similar to that? Very nicely done. All right. So here we have a problem of 3 polynomials. And one of them, this one is factored. These two are not, and they have 4 terms. All right. So they want first, what is the value of f of 7? All right. So if I have f of 7, and I should do my blue. Let me do the blue. Hold that thought. Let me do. Might show up better. F of 7. That means I would have, for every place x is, I'm putting a 7. 7 minus 8, 7 plus 9. All right. Well, this is 0. This is a -1, and this is a 16. Well, what is anything times 0? Well, of course, it's 0. So, what is the value of f of 7? F of 7 equals 0. Now it says, for what values other than 7 is f of x equal to f of 7? So we're saying what else is equal to 0. So we already know then that we set the factor equal to 0 and solve for x. So this is x equals 8 and x equals -9. So for this, x can equal 8 or -9, and it equals f of 7. They're going to get 0. Right. So here we have the g of x, and I have a typo as normal, and it is x cubed plus 2x squared minus x minus 2. And it wants g of -2. All right. Now, in something like this, we can use the calculator or we can do the little math. And this is little math. And I want to review some things of what happens when we have negative values and we operate with them. So a -2 cubed is a -8. All right, now I want you to see that, so I'm going to put it up here. -2 times -2. Sorry about that. Okay. Times a -2 is a negative. And 2 squared is +4. 2 negatives make a positive 2 minus 2. That's a -8 plus 8. Okay, so that's 0 plus 2 minus 2, 0. So this is equal. Now we want g of -1. All right. So I have a negative 1 cubed plus 2 times a negative 1 squared minus a negative 1 minus 2. All right. So this is a negative 1, a positive 1, and a negative. Again, we get 0. All right. So guess what 1 is? Well, 1 is the same thing, isn't it? Well, let's find out. So I have g of 1 cubed plus 2, 1 squared, minus 1, minus 2. Okay, well, this is 1. This is 2, negative 1, negative 2. Well, this is also 0. So what this tells us is that these are factorable items, all right? So based on the one above, what do you think the factored form of g is? Well, we're saying x equals negative 0, sorry, or x equals 0 at when y is negative 2. So we're saying, so we're going to say that, okay, we're going to use our y value, our x value. So y is 0 when x, I'm sorry, I wrote that wrong, didn't I? Y equals 0, x equals, and in this case, a negative 2, or a negative 1, or a 1. So if we add them back, x plus 2 plus 1 and x minus 1 are the factors. They create what we had up here with our f of x, the factored form. Now they want us to factor this guy. Well, if we don't have a clue of the zeros, we do some F4 terms. We find the GCF for each pair. Well, this one is 2x squared. If I divide 2x squared into x cubed, I get x. If I divide 2x squared into 4x squared, I get a plus. I'm going to take out a negative 2, and that gives me a positive x and a positive 2. Well, now what I notice is that they share the same factor. So I'm going to divide by that x plus 2, or factor it out, and I'm going to have 2x minus 2. Right. Now, I could pull out a GCF, but I think this is all at once. If I was to take out a 2 here, I would say h of x equals 2, because that's a shared amount for that. 2 parenthesis x plus 2, x squared minus 1. Well, now we need this factor, because that's the difference of perfect squares. I can have it as 2 x plus 2, x minus 1, x plus 1. And now it is totally factored. All right, now this might be troublesome for you, but look at what we did. So now you're ready to do the homework. Thank you for listening.